Hi, welcome to the video series on operating system. Here we are discussing about the storage device hierarchy. In this storage device hierarchy, we are discussing about the definition and explain the different levels of storage hierarchy, including registers and cache main memory, and discuss the traits of between the different levels of storage, the terms of speed, cost, and capacity. Here you can see the definition. Memory hierarchy is an improvement in computer systems design that arranges memory to reduce the access time. The location of reference program behavior serves as the foundation for the development of the memory hierarchy. The memory hierarchy several styles and indicated in details in the following figure. You can see that, and here why it is required and why what is the important features in this storage device hierarchy. Why memory hierarchy is used to maximize computers used for memory, balance, capacity, and cost of it. What is the important features varying in cost and size and speed? Faster memory is more expensive and has lower capacity, such as cache and main memory. Secondary and tertiary storage, which is slower memory, is less expensive and has larger capacity. Memory types different in terms of access speed. Here see you can see the computer memory hierarchy is increasing cost and bit but frequency accessed by the CPU and increasing capacity. You can see the increasing bit. If increasing cost or byte increases but frequency of access by the increasing capacity and access time, you can see decreases. You can see register cache and you can see the memory hierarchy design. And in hierarchy design, you can see the register. The CPU contains TD and fast memory modules called register. The most often utilized information and instructions are kept in them. With a typical capacity of 16 to 64 bits, register have the smallest storage capacity and fastest access time. And cache memory. It is a quick access compact memory module that sits next to the CPU. It holds recently accessible instructions and often utilized data from the main memory by the giving CPU instant access to frequently used data. Cache memory is intended to reduce the amount of time retrieve the data. Next thing is main memory. It is referred to as RAM, random access memory, serves as a computer system primary memory. Although it is slower than cache memory, it can store more data. The data and instruction that the CPU is now using kept in the main memory. Main memory type static RAM and dynamic RAM. In static RAM, use flip flops to store binary data, which is only valid while power is applied. It implements cache memory and offers fastest access time. And dynamic RAM. It uses two capacitor to store binary data as a charge. After a few miles milliseconds, the circuit needs to refreshed in order to keep the capacitor charged. Compared to SRM, it's more cells and per unit area. Secondary storage. Secondary storage is non-volatile memory type of high storage capacity than main memory. Examples of these types of storage are hard disk drives and solid state, which the CPU is not using the data or instructions that they are stored there. In the memory hierarchy, secondary storage has the slowest access speed and it's usually the most affordable type of memory. Magnetic disk. Magnetic disks are essentially circular plates made of plastic or metal or magnetized material within the computer, and magnetic disks are often used to operate the high speed. Magnetic is essential plastic film covered magnetic recorded device. It is a type typical utilized for data backups. A computer access time for magnetic tapes is a little slower, therefore, it takes some time to access strips in this scenario. Characteristics of a memory hierarchy is capacity. It speaks of the overall amount of the data memory the system is capable holding. As one moves down the memory hierarchy from the top to the bottom, capacity rises. Access time. It speaks the amount of time that elapses between the read and write request and the availability of the data. As we descended the memory hierarchy from the top to bottom, the access times grows. And next, performance. Due to the significant difference in the system access time, the speed differential between the allocated CPU registers and main memory grown in previous computer system that did not use the memory hierarchy. It ultimately caused the system to operate worse, necessitating improvement. Memory hierarchy design was one such improvement that was added, and a result that system performance improved. Reducing the amount of memory hierarchy thus must be used in order to modify data in one of the main strategy for improving system performance. Cost per bit. Moving up memory hierarchy, raising the cost per bit. That is, external memory is more expensive than the internal memory. Here you can see the memory hierarchy. Here, sorry, you can see the every hierarchy step. You can see the cost, capacity, and speed. You can see in register step. So it is super fast, super expensive, and tiny capacity. And level 2 and cat faster and expensive and small capacity. And physical memory like secondary memory fast, price reasonable, and average capacity. In primary memory, average speed, price reasonable, and average capacity. And mechanical hard drives in virtual memory means slow, cheap, and larger capacity. Here you can see the some of the questions on what does memory hierarchy means to you. A straightforward way of you can see what does memory hierarchy means to and describe the various memory hierarchy kinds. How would the memory hierarchy listed in DBMS? The following illustration of memory hierarchy in database management: CPU, register, memory cache, and primary memory and main memory. You can see here the questions and answers. Thank you.